I did it one way. I don't think anybody did it the way I did, but there was two other ways that people did it were just fine, right? So these kinds of verifying, you're going to have different ways to get to the same place. What I did is I thought there's a cotangent in both terms. Why don't I factor it out, right? So if I did, I'll do it over here to leave space to show another representation of the same thing. If I factor out a cotangent of x, then I'm left with secant squared x minus 1 on the left, right? But secant squared minus 1, I mean, as soon as you see it, you should be thinking, oh, we have substitution for that, right? That would be secant squared minus 1 is tan squared. So substitute cotangent x times tangent squared x, right? But cotangent of x is 1 over the tangent. So then you could write that as tan squared x over tan x and cancel tan x, which is the right-hand side. Most did this. They said, I'm going to take this secant squared and substitute tan squared plus 1. Okay. And now I'm going to say this cotangent is 1 over the tangent. So now I've got tan squared plus 1 over the tangent minus the cotangent. And then I'm going to write this, I'm going to split this up right into tan squared x over tan x plus 1 over tan x minus cotangent of x. And then tan squared over tan is tangent. 1 over tangent is cotangent minus cotangent, right? These two cancel, and that's the answer, tan x. That's what most people did who got it. What was the other one that somebody did? No, I'll give them to you. You have to know how to use them, though. Then there's no excuses, right? Somebody else did this. I think they divided. They did like this. Divide everything by cotangent. Right, but if you divide tangent by cotangent, that's like saying tangent times tangent. That's tangent squared. Right. On this side, the cotangents cancel. This is 1. So secant squared minus 1 equals tan squared. There you go. So 3 different ways of doing the same thing.